We're going to look at solving simple linear inequalities and some vocabulary first. The first one, a linear inequality in one variable. It's the same thing as a linear equation except the equal sign will be an inequality sign. So it's going to be greater than, less than or equal, greater than or equal to, or not equal. And remember, a linear equation is a type of an equation that can be written as y equals ax, and where our exponent of the x is just a 1. Now the next one, a solution. A solution is any value that makes your statement true. So if I have the inequality x is greater than 7, a solution could be 10 because 10 is greater than 7. A solution could be 215 because 215 is greater than 7. Now 3 would not be a solution because that would be false. 3 is not greater than 7, so that would not be a solution. So it's any value and all values that make your statement true. Okay, as far as solving linear inequalities, we still do the order of operations just like it was a linear equation. So we still undo every single thing there. We undo addition, we undo subtraction. The only difference is if you multiply or divide by a negative, you must flip the sign. That is critical. And that is only if you multiply or divide by a negative. That is the only exception. Otherwise it follows just like an equation. So here's our first two problems. The one on the left here, 2w plus 8 is greater than 14. As I look at this, I'm trying to solve it for w, my only variable, and so the first thing I have to get rid of is addition and subtraction, because remember, you undo your order of operations when you're solving for the variable here. So I'm going to subtract 8 from both sides, and just like with equations, I still have to do the same thing to this other side here. So on the left, this 8 minus 8 turns out to be a 0, and then I have 2w is greater than, and then 14 minus 8 gives you a 6. Next thing I need to do is get rid of the 2. Well, since it's 2 times w, I have to undo timesing by dividing. So I have to divide both sides by 2. Now I divided, but since it was not a negative, I just divided by a regular 2, my sign stays the same. So on the left side, my 2's cancel out to be 1's, so I'm left with w is greater than 3. Now to graph this, I go down here to my number line. I'm going to put 0 on here. I'm going to put 3 on there. And I am going to be using an open circle. Now if you don't remember from your previous classes when to use an open circle or a closed circle, if you have less than or greater than, this would be an open circle. If it has the equal to portion, less than or equal or greater than or equal to, this is going to be a solid circle. And the reason for that is because think about if you graph a number on a number line, let's say you graph the number 2, you put a dot because you're graphing x equals 2. So it's indicating that that is included, x is, or that you have an equal sign, which is why we have a solid circle here, is because we have the equal to component. Now up here, if you were to graph x is greater than 2 or 0, that's indicating that you can have everything bigger than 0, but you can't actually have 0 itself. So it would have an open circle to indicate that we can get as close to this 0 as we want, but I can't actually have that 0. So make sure you're very, very aware as to whether you have an open circle or a closed circle. So back to my problem. I'm graphing w is greater than 3. Well, 3 is my cutoff point, and I am going to use that open circle. And now I want the values that are bigger than 3. Well, if I'm not sure which way to go, I can do a test point. So I'm going to test the point 0. And if my test point is true, it means I shade that direction. If my test point is false, I shade the other direction. So my test point, 0 is greater than 3, that is false. So that tells me my test point was false. So instead of going to the left, I need to go to the right. Now the reason we have this shaded arrow here is because it's actually anything this direction will satisfy this inequality. So we no longer just have one single answer. We have this whole group of answers. It could be 3, it could be 10, it could be 14.5. All of those are represented by shading this direction and putting the arrow on it. Okay, the next one. Same situation here. I've got one variable, an inequality. I'm going to start by getting rid of addition and subtraction again. So I have to get rid of this positive 10 here, and I do that by doing its inverse, minus 10. And on the left side, I'm left with negative 3t is greater than 5. Now, even though we had like a negative 10 here, it wasn't multiplying or dividing, so my symbol stays the exact same way. It's only if you multiply or divide by a negative that you flip it. Okay, now at this step I need to get rid of timesing by negative 3, so I have to divide both sides by negative 3. And here is where my sign is going to flip. Because I'm dividing by a negative, I have to flip my sign. On the left side I have t, but now instead of greater than, I have to flip that sign around to be less than. And I'm going to leave it as negative 5/3. When I go to graph this one, I'm going to go use an open circle again, and it's going to be at negative 5/3. And then I want values that are less than negative 5/3. So another way that you can decide to graph is just to think about, okay, which direction is less than negative 5/3? Well, that is to the left. The numbers to the left are smaller than negative 5/3. Or if you're not sure, you can do a test point again. Plug in a 0. Is 0 less than negative 5/3? Well, that's false, so my test point, which is on the right, turned out to be false, so I would again shade to the left. Okay, practice 2. Solve and graph the solution of each. Go ahead and pause the video. You're still going to follow the same types of algebra rules as with linear equations. Make sure you watch out for dividing or multiplying by negatives. So pause the video and see what you come up with. Alright, on the left side, I distributed the 7 out first to get rid of those parentheses. So I had 21 minus 7t is greater than or equal to 28. Then since I had t only in one spot, I decided I needed to get rid of that 21. And since it's a positive 21, I needed to subtract it off, so I subtracted it from both sides to keep it balanced. And I was left with this green line here. Negative 7t is greater than or equal to 7. Then divide both sides out by negative 7. And right here, I divided by a negative, which means I have got to flip that sign. So I then ended up with t is less than or equal to negative 1. Come down here to graph it, and I have a closed circle because it has the equal to part with it. So I have a closed circle on negative 1, and then since I want values that are less than negative 1, I want smaller, so that means I shaded to the left. On the second one, this time I've got t in two different spots, so I need to bring them together. I decided to move the 4t over to the left. It doesn't matter, you could have moved the 5t over to the right and that would have been fine. When I did that, I got 9t plus 9 is greater than or equal to 7. And then I needed to get rid of this plus 9 right here, so I subtracted it off. And remember, since it's just subtraction, it's not multiplication or division, I don't have to worry about flipping the sign. Left with 9t is greater than or equal to negative 2. Divide by the 9, and here I divided by a positive, so I do not switch the sign. So this one is t is greater than or equal to negative 2/9. And again on this one I'm going to have a closed circle because it has the equal to portion with it. And then since I want t to be bigger than my cutoff point there, I need to go to the right where the bigger values are.